Carbon and its compounds. Food, clothes, medicines, books, or many of the things that you listed are all based on this versatile element, carbon. The amount of carbon present in the Earth's crust and in the atmosphere is quite meager. The Earth's crust has only 0.02% carbon in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum, and the atmosphere has 0.003% of carbon dioxide. In spite of this small amount of carbon available in nature, the importance of carbon seems to be immense. Bonding in carbon. The covalent bond. Ionic compounds have high melting and boiling points and conduct electricity in solution or in the molten state. Melting and boiling points of some carbon compounds. Compound. Acetic acid. CH3COOH. Melting point 290 Kelvin. Boiling point 391 Kelvin. Compound chloroform. CHCl3. Melting point 209 Kelvin. Boiling point 334 Kelvin. Compound ethanol. CH3CH2OH. Melting point 156 Kelvin. Boiling point 351 Kelvin. Compound methane. CH4. Melting point 90 Kelvin. Boiling point 111 Kelvin. From the data on the boiling and melting points of the above compounds, we can conclude that the forces of attraction between these molecules are not very strong. Most carbon compounds are poor conductors of electricity. These compounds are largely non-conductors of electricity. We can conclude that the bonding in these compounds does not give rise to any ions. Let us now look at the electronic configuration of carbon. The atomic number of carbon is 6. The reactivity of elements is explained as their tendency to attain a completely filled outer shell, that is, attain noble gas configuration. Elements forming ionic compounds achieve this by either gaining or losing electrons from the outermost shell. In the case of carbon, it has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration. If it were to gain or lose electrons, first, it could gain 4 electrons forming C- anion. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Second, it could lose 4 electrons forming C4+ cation, but it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Not just carbon, but many other elements form molecules by sharing electrons in this manner. The shared electrons belong to the outer shells of both the atoms and lead to both atoms attaining the noble gas configuration. Before going to compounds of carbon, let us look at some simple molecules formed by the sharing of valence electrons. The simplest molecule formed in this manner is that of hydrogen. The atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and it requires 1 more electron to fill the K shell. So 2 hydrogen atoms share their electrons to form a molecule of hydrogen H2. This allows each hydrogen atom to attain the electronic configuration of the nearest noble gas, helium, which has 2 electrons in its K shell. The shared pair of electrons is said to constitute a single bond between the 2 hydrogen atoms. A single bond is also represented by a line between the 2 atoms. The atomic number of chlorine is 17. Chlorine forms a diatomic molecule Cl2. In the case of oxygen, we see the formation of a double bond between two oxygen atoms. This is because an atom of oxygen has 6 electrons in its L shell. The atomic number of oxygen is 8 and it requires 2 more electrons to complete its octet. So each atom of oxygen shares 2 electrons with another atom of oxygen. The 2 electrons contributed by each oxygen atom give rise to 2 shared pairs of electrons. This is said to constitute a double bond between the 2 atoms. Depict a molecule of water showing the nature of binding between one oxygen atom and 2 hydrogen atoms. The molecule has single bonds. Nitrogen has the atomic number 7. In order to attain an octet, each nitrogen atom in a molecule of nitrogen contributes 3 electrons, giving rise to 3 shared pairs of electrons. This is said to constitute a triple bond between the 2 atoms. The electron dot structure of N2 and its triple bond can be depicted. A molecule of ammonia has the formula NH3. Draw the electron dot structure for this molecule showing all 4 atoms achieve noble gas configuration. Methane, which is a compound of carbon. Methane is widely used as a fuel and is a major component of biogas and compressed natural gas (CNG). It is also one of the simplest compounds formed by carbon. Methane has a formula CH4. Hydrogen, as you know, has a valency of 1. Carbon is tetravalent because it has 4 valence electrons. In order to achieve noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen. Such bonds which are formed by the sharing of an electron pair between 2 atoms are known as covalent bonds. Covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are small. This gives rise to the low melting and boiling points of these compounds. The electrons are shared between atoms and no charged particles are formed. Such covalent compounds are generally poor conductors of electricity.